Hello everyone. Today we're going to work on section 12.2, surface area of prisms and cylinders. There's a blank lesson for you, of course, in Schoology in chapter 12. So here is just kind of a review of what we covered in 12.1, just some of the anatomy of a prism. It's a polyhedron. Remember, a polyhedron is made up of two congruent bases that lie in parallel planes, and they have faces that are polygons. So in a prism, you have two bases that are parallel and congruent. And you also have what are called lateral faces. And that's going to come into play a little bit today when we find surface areas. We're going to find the area of the base, multiply it by 2 since they're congruent, and then we're going to find the area of all the lateral faces and add it together. So again, some reminders about prism. It's a polyhedron, two congruent bases. These bases right here are always parallel to each other, and they're not always resting on their base, so be careful about that. Also, all the rest of the faces are quadrilaterals, okay, which really means they're usually rectangles or parallelograms, but most of the ones we are going to do are right prisms, so they'll be rectangles. And that's another way that you can tell which is the base and which are the faces, because you can see the base here. These could not be lateral faces because they are not quadrilaterals or rectangles. So we have right versus oblique prisms. The good news is we're not going to really be dealing much with the obliques. And the good news is we basically calculate the values the same. But in a right prism, the lateral edges right here, okay, are perpendicular to both the bases. And in an oblique prism, some of the lateral edge right here is not perpendicular to that base, both bases. And remember, this is really important also, is that the height is always the perpendicular distance between the bases. So that is always going to be true, and just like other times, sometimes it has to be drawn outside the actual prism. Okay, so we have what's called net drawings. And so when you have a prism here, okay, and this is one of the bases, we're going to draw one of those, and we're basically going to unfold it and think about folding these down and laying them all out, and then this is kind of going up towards the top. Well, if you just look at this, we can actually find the area of each one of these rectangles, add them together, and find the area of one of the bases, multiply it by 2, add all those together. So that's really what surface area is. It's the square units that fit around the outside of a prism or pyramid or cylinder, etc. So surface area is really just simply the sum of all the areas of all of its faces. The lateral area is the lateral faces, and then the net that we have is a 2D representation. So again, here we have this, and if this is the base right here, and I fold this down right here, and I fold this down right here, that would be these two faces right here. This is actually, all the dimensions are exactly the same, a cube, so all of the dimensions will be the same. So this is 8 by 8, but this is also 8 by 8, etc. So this one, pretty simply, we can find the surface area of this base, which is 8 times 8, and then we can multiply it, since they're all congruent, by 6. So we get a surface area of 384 units squared. Now, sometimes they're going to start talking about the lateral area. The lateral area is all of these, okay? So those are the lateral area. It's these pieces that are on the side. It's everything except the two bases. And this would be sort of the top of the cube. Okay. So the lateral area ends up getting calculated really by the same things we've been using, by taking the perimeter of the base times the height. So we could go through a lot of these examples, but again, I'm kind of concerned about timing on this, but I'll try to show you that if we have this net right here, and here's our base, right here. We have, this is 5, and this is 10, and then this piece right here is 14. So if we're finding the area of that base, it's going to be 10 times 14 times 2. And if we're finding the area of this face right here, that would be this back right there, okay, that is going to be 10 by 5. So we have, and again, we have two congruent ones. And then we also have this right here. Okay, let's try again. See if I can get this other color. There we go. So we have this. Oops, that was not it. Sorry. Highlighting the wrong one. It's this one right here and this one right here. And those are 5 by 14. And again, we have two of them, so we just add those together. Well, what you might notice here is we could actually take this part of our formula right here, and we could factor out a 5. And if we do that, that 5 is actually this height right here. And then when we look at 2 times 10, then that's left from this expression right here, plus 2 times 14, that's left from this expression right here. What this value right here, what all of this really is the perimeter, because you're taking 10 and 10, that's 10 times 2, and you're taking 14 and 14, 14 times 2, and that inside there is really our perimeter. So, to calculate the lateral area, that's all of our lateral areas. All we have to do is take the perimeter of the base, multiply it by the height. And then we add that to the area of the base. So this is the area of the base, and we multiply that by 2 because we have two of them. And so that's just sort of an explanation of the formula. I didn't even calculate it all, so we're going to be practicing several of those. So this is sort of, instead of having to find each individual face and add it together, this will help us do it much more efficiently. So the surface area, okay, of right prisms is to take the area of the base times 2, and notice that we use capital B for that base area. That's important, okay? And then we are going to notice that we have the perimeter of the base times the height of the actual prism. So take a minute right here, this is the perimeter, and pause the video and write this down. Make sure you're describing and defining what each of these values are. And, you know, a lot of the homework questions that you might encounter are going to ask you to calculate the lateral area. This is the lateral areas. Those are all of the faces except the base and its congruent parallel counterpart. So let's see if we can try some examples. Okay, so one thing you always need to do is make sure you know what the base is. So find the surface area and lateral area of the right prism. So our surface area is equal to the area of the base times 2 plus the perimeter of the base times the height. So start with that. Well, your base right here is actually a triangle. This is your base. Okay, so to find the area of that base, you need to have this base right here. Lowest, that's a lowercase b, and we have an uppercase b, so you have to be careful. But when we're calculating the area of that base, we are just going to need to use the Pythagorean theorem. So 7 squared is equal to 3 squared plus b squared. So that is going to give us the square root. So we take 49 minus 9, that b is going to be the square root of 40. And I could get a decimal for that, and that's not even in simplest radical form, but that's okay. So to find the area of the base, it's a triangle. So it's 1/2 the base of the triangle, which is this that I just found, the square root of 40, times the height of the triangle, which is 3. Okay, then I have to multiply that by 2 because I have those two bases. So now I need the perimeter of the base. The perimeter of the base is 3 plus 7 plus the square root of 40. So the perimeter of the base that I'm going to add is going to be 3 plus 7 plus the square root of 40. I'm kind of running out of room, but then I have to also multiply that by the height, which is 11. So let's see if I can maybe make this a little bit neater here for you. So we're adding the 3 plus the 7 plus the square root of 40, that's the perimeter, times the height of the actual prism. So when we add up all these, if we want the lateral area separately, okay, then we're going to calculate this piece right here. This is our lateral area. And that happens to be 179.57. And then we're going to add it with the area of our base times 2, which is 19 point, or sorry, let's try that again. Whoops. That is, I read my calculator wrong, so that is 18.97. So now, calculating all that together, you would have 198.54 units squared. So that's how we use the formula, okay? And again, some of your homework questions are going to ask you for specifically the lateral area and the surface area both. Make sure you're showing your setup in your homework questions. I notice a lot of you are just kind of blindly putting answers down. Make sure you're working on justifying your thinking. Okay, so these get a little more complicated at times, especially when you have regular polygons, and you're going to have to use that formula for regular polygons, which is 1/2 the apothem times the perimeter. I'm going to skip this example right now. I'll go back and fill it in, but let's do maybe this one, okay? So it says, find the surface area of a right hexagonal prism with height of 16 and all base edges measuring 8. So we know that all of these base edges right here are measuring 8. We know that that is the base because it tells us it's a hexagonal prism, and they're always named by the shape of their base. The height is 16, and it gave us the height. So now what we need to do is, if we go back here and write our formula, our surface area is equal to the area of the base times 2 plus the perimeter of the base times the height. So do we know these things right now? Well, I do know the perimeter of the base because the perimeter of the base is 8 times 6. Or 48. So 8 plus 8, so all of these are 8. So when I calculate that perimeter, that's just going to be 48. I also know the height of the prism right here. There's my height. Okay, so I got all that work done already. All right, great. So now let's work on the area of this base. That's a little trickier. Now we're probably going to have to use Traeger 30, 60, 90. So remember, inside all of these regular polygons that we did in chapter 11, okay, it can be broken down into congruent isosceles triangles. So what we need to do is we need to find the area of the base using that the area of that regular polygon is 1/2 the apothem times the perimeter. Okay, so I'm going to have to work on that. So remember that each one of these angles inside is congruent, so that makes this angle right here 60 degrees. So now when I'm trying to find the height of this triangle, it makes this smaller angle 30. So I'm going to draw out above here this triangle, and I know this is a 90 and this is a 30, and even though my triangle is a little messed up as far as proportion wise, well, I guess I can fix it here a little bit. So what we have here is 30. We have a right angle here, and we are trying to find this apothem. We know that this part right here is 4, okay? Because in an isosceles triangle, the height is also the angle bisector and the perpendicular bisector of that side. So now what I have is a 30, 60, 90 triangle. And you could use trig, but we know that this is x and this is 2x. And then A is going to be x root 3. So my apothem is 4 root 3. So there's my apothem. Now I need the perimeter of that regular polygon. Well, again, the perimeter is 1/2 the apothem times the perimeter, and the perimeter is 48 again. Okay, so now I found the area of the base, which is 1/2 times 4 root 3 times 48. Now I have to multiply that by 2. So if we go ahead and calculate all this out, we have 0.5 times 4 root 3, and then we multiply that by 48, and then multiply it by 2, and that gives us 332.55. Then we take our perimeter times 16 times 48, and that gives us 768. So this is our lateral area right here. So 768 is our lateral area if they ask for that. And when we add them all together, we should get 1,100.55 inches squared. All right, so again, some of these are going to get kind of more complicated as you go along. I'll try to work out some more examples, but let's move on to cylinder. So a cylinder, even though it's not a polyhedron because it's not made up of polygons, we can still calculate the surface area of a cylinder. So a cylinder has 2 congruent circular bases. Okay, so here's one of the bases and the other one is down here. The bases again are parallel and they're connected perpendicularly by a height. So again, just like in prisms, we have right and oblique. So just be conscious of where your height is because sometimes it is drawn outside your cylinder. So what's interesting about a cylinder is if you were to open it up, okay, like made of cardboard, what you're going to find out is that this lateral area right here really unfolds into a rectangle. And if you think about how to find the area of a rectangle, you know that the area of that rectangle is just the base times the height. Well, this base right here is really from this. And what is that? That's the circumference. So that base right there is your circumference. So the area of the rectangle is the circumference times the height, which in this case would be 15. And then we're going to take, that's the lateral area. So we're going to take the circumference, which we know is pi times the diameter. And we're going to add that with the area of our base times 2. And our base is a circle, so we could fill that in, pi r squared. So it's 2 pi r squared plus pi times that diameter, or we could do 2 pi r, either one. Okay, but this is our surface area, and that's why. And it's fairly straightforward and easy to, they're actually easier to do than prisms. So here's your formula, and notice it's identical. Okay, I would just encourage you to memorize this part of it because it's identical to the prism. And then just fill in that your base is a circle. And that will never change for cylinders, but it will for all of the other prisms. So you don't need to memorize this one special. Okay, and you know the perimeter of the base is just your circumference. So Again, we talk a little bit about lateral areas, that's that rectangle, and then the base areas, we add those together to get the combined surface area. So let's practice one, all right? Find the lateral area and surface area of the right cylinder. So your surface area is the area of the base times 2, because you have 2 of them, plus the perimeter of the base times the height. So my base is a circle, so it's going to be pi times my radius squared. My radius is 7. Then I have the perimeter of my base, which is my circumference, so 2 pi times 7 times the height, which is 10. And that's it. Okay, and like I said, these are actually usually easier and faster to calculate. So my lateral area is actually, if I do it in simplest exact form, I would have 140 pi is my lateral area. Okay, this is lateral area, which that is approximately 439.82 for the lateral area. So that is this area right around in here, all the way around. So there's your lateral area. Okay, then we're going to have to add that with the base area, which is 49 pi, or again, my 49 times 2, this would be 98 pi, which is approximately 307.88. When we add these together, my total surface area then becomes 747.7 units squared. All right, so this is getting, I'm sure, lengthy video-wise, but I'll just go through maybe 1 or 2 more. If you feel like you have this, you could skip to the homework, but I'm going to do some of those working backwards ones because I think those get to be kind of tricky. So this question says the surface area of the right rectangular prism is 548. So now they want us to find the value of x, okay, which is part of the base. So again, I'll start with my formula. Surface area is the area of the base times 2 plus the perimeter of the base times the height. So my surface area I know is 548. That equals 2 times the area of the base. My base is 7 times x plus the perimeter of the base. Well, I have 7 plus 7 plus x plus x. So the perimeter of my base is 14 plus 2x times my height, which is 10. So you got everything plugged in, but this is where it can get kind of tricky. I would probably use the distributive property and take care of simplifying 140 plus 20x. And then that has to be added with 14x. And then that equals 548. Now I can combine the x's right here, and that's going to give me 34x plus 140 equals 548. Subtract 140 from each side, that gives me 408 equals 34x. Divide by 34 and I get x equals 12. Okay, so sometimes students have trouble with the algebra and what to substitute in and so forth, and even just finding sort of that perimeter and area of that base. So I wanted to go through at least one of those. Here's another cylinder one working backwards that I think I'll work out on the actual notes. But here are your learning targets, and again, I have decided, at least for right now, that I am going to try to let you kind of decide which problems you need to do. I'm not making you do a certain number, but you should be justifying your work and showing your work and not just putting answers down. Okay, here's some guidance for some kind of key problems. All right.